Okay, so this video is about Newton's second law of motion and the kinematic equations and how we can relate these two subjects or ideas together. So before we get on to kinematics, I just want to reiterate Newton's second law of motion. We went over this, I know, in class, but I cannot state this enough. The big idea that I'm trying to get across here is that motion does not require a force. It's very common for a lot of people, to first of all believe it does because that's their everyday experience. And I've noticed that in a lot of our free body diagrams, that comes across as well. The free body diagrams that you guys do in class. So I want you guys to kind of get away from that and realize that a change in motion, so acceleration, is the thing that requires a force. And so what Newton's second law does is it relates this force, and technically, when it's not just any force, it's the net force. Okay, so this is the sum of all the force vectors. Okay, so if we have a bunch of forces acting on an object, we add all the force vectors together, and this is our net force. So the net force is equal to the mass of the object times its acceleration. And we could rewrite this a little bit. Very often this law is stated as acceleration is equal to force divided by mass. So what this is, it's a little bit easier to see here, that the larger your force is, the larger your acceleration will be, which makes sense. And for any given force, the larger your mass is, the smaller your acceleration is going to be. Remember when we do this that you have to keep control of your units. So your mass has got to be in kilograms, your acceleration is in meters per second squared, and this net force will be in terms of newtons. So make sure you keep all that straight. All right, so this is Newton's second law, and this is how we can calculate an acceleration if we know what the net force and the mass of the object is. So one situation where we'll apply Newton's second law is in a state of equilibrium. So in physics, equilibrium refers to a situation where the net force on the object is zero. So there will be no acceleration of the object in this case. And knowing this, we can kind of reason out what the unknown forces are on the object. So here's an example problem. We have a shed on top of a platform, right? And maybe it's next to the beach or something, and you want to protect it from, hurricanes or if the storm surge comes in. So you have it up on these pillars, and it's supported by 3 pillars, maybe kind of like in a triangle. And the question is, what is the force that each pillar exerts on the shed platform system? So this is something that an engineer would worry about, right? So if you're building this and you're wondering, okay, how much force do each of these pillars need to be able to hold or withstand? At the very minimum, it has to be able to support the structure. So when we look at all the forces, so this is going to be my shed and platform right here. What we would have is we would have a downward force, which I'm going to call the force of gravity. And then we essentially have 3 upward forces from the 3 pillars, and those will all have to be equal. Okay, so maybe force a pillar, and there's 3 of those. Okay. Now be careful with this because in the problem I said that it has a mass of 1,200 kilograms, and a lot of students will say, oh, okay, a mass of 1,200 kilograms, that must be the force. Remember that there's a difference between mass and weight. Mass is how much stuff something has in it, and no matter where you are, it's going to have the same mass. Whereas weight is the force of gravity. Okay, so I want you guys to kind of differentiate between these two. Weight is equal to the force of gravity. So if there is no gravitational field in a region of space, something will be weightless. There'll be no force of gravity on it, but it will obviously have mass. So the way we calculate the weight of an object is we take its mass times the acceleration due to gravity at wherever it is in space. So in this case, the weight, this force of gravity, will be the 12,000 kilograms think I said 1,200 before. It's 12,000 kilograms times the acceleration due to gravity. Now, just to make this quick and easy, I'm going to put 10 meters per second squared. We know it's, to 3 sig figs, it's 9.81, but I'm just going to use 10. And so we would say that this would have a weight of 120,000 newtons. Okay, so do not use kilograms when you really need to use newtons. And as I said, we have 3 pillars, maybe pillar 1, pillar 2, and pillar 3. And it's not accelerating. This the shed and the platform will be stationary. It's not going to accelerate. It's going to have a constant velocity of 0. And so what has to happen is that the sum of these 3, I'm going to call this maybe force of pillar 1 plus force of pillar 2 plus force of pillar 3. The sum of these 3 upward forces has to equal the weight. Because if I add all the forces together, let's make up positive. So if I add these 3 positive forces and this one negative force together, the whole thing's going to have to be 0. Okay, we could say essentially FP1 plus FP2 plus FP3 plus Fg will be 0 newtons. Keeping in mind that this is actually going to be negative because we're going to be adding these together like vectors. Okay, and so if I rearrange a little bit, I'm going to get this. And I know that all 3 of these forces have to be the same. So essentially I can say that 3 times the force on any one pillar has to be equal to my weight. So this will be 120,000 newtons. I solve for Fp, so I divide this by 3. And what I would get is I would get that each pillar needs to support a weight, the force on each pillar will be 40,000 newtons. Okay, so this is an equilibrium problem. And again, look at my reasoning here. I didn't know what these 3 forces were, but I knew that this condition right here had to be true. That because the net force, because it wasn't accelerating, the net force had to be 0. Therefore, I could say this, and then I could rearrange things. I can solve for my missing forces. Now, the net force won't always be 0. Okay, if it was, it'd actually be kind of boring because then nothing would accelerate. What would accelerate? So when the net force is not 0, when we have these unbalanced forces that don't cancel out, we have acceleration. And what we do is we use Newton's second law to calculate what the acceleration is. And then knowing the acceleration, we can then go back to our kinematic equations to calculate the speed, the distance, or the time. So I have a sample problem here. A car engine exerts a force of 5,000 newtons on a 2,000 kilogram car. The combined effects of air resistance and friction exert a force of 1,500 newtons. If the car is initially traveling at 10 meters per second, how much time is needed to reach a speed of 25 meters per second? So drawing my free body diagram, I would say that I have a force of 5,000 newtons going this way, and I would have a combined force opposing the motion of, 1,500 newtons going the opposite way. Again, I'm going to make that positive. Don't forget to find which way is positive. And then the next step in this is I need to calculate my net force. So my net force will be a positive 5,000 newtons plus a negative, because it's pointing off to the left, 1,500 newtons, which leaves me with a net force of 3,500 newtons. Okay. Now, I know that F net is equal to mass times acceleration. And so what I can do is I can calculate my acceleration. I can say, okay, acceleration, if I divide both sides by mass, will be F net divided by mass. So I can say that this will be my 3,500 newtons divided by the mass of the car, so 2,000 newtons. And if I do this, I would get 1.75 meters per second squared from acceleration. But we're not done yet. It's not asking me about acceleration. It's asking me about time. So then I have to go to a kinematic equation that will give me the time I need. And what I know is I know the initial velocity. So I know V naught. I now know my acceleration. Okay. And I'm asked for time, and I know this as well. So this will be my VF. So look at my kinematic equations. I have this. I have VF is equal to V naught plus acceleration times time. I want to solve for time.